So, we already talked about some of this stuff last lesson, so we've actually gone into this lesson with the last lesson, so it should be quick. We have a whole bunch of ways here which we can represent our relations. So you'll have to be able, this is kind of like a checklist for you. You should be able to do all these things by words, equation, function notation, which we haven't seen yet, table of values, which we saw, that's when we plugged in the values. Mapping diagram we did, ordered pairs we did. Ordered pairs is your coordinates. So when you put in the brackets, but it's a different way of doing that. So we'll show you that. Yeah, Josh? Yes, sir. I want to backfill, yeah? I want to backfill. And graph, which you've already done. So, this is your table of values. You've seen that. Your ordered pairs is your brackets. It's not just one coordinate, it's a whole bunch of them. Those are just called ordered pairs. You might see them also listed like this, with a curly bracket and then little brackets. And then, so that's also ordered pairs. So you might see them like that as well. Graph we did. This is your mapping diagram. So you're going to be given a list of numbers and a list of another numbers, and you just draw an arrow connecting the two. Kind of like when you do those on tests where you're just doing matching questions. It's almost like that. You're just matching the numbers with the correct one that it would line up with. So given some information, you could make the connections. That's just called a mapping diagram. Yeah, Matthew?
How come sometimes there's two lines with one axis?
That's a good question. Remember how we discussed that sometimes two pieces of data might have the same thing? So if we did people in here whose names were Matthew, you know what I mean? So we had, there's two. So you would have two people pointing to that one. So, I'm the second one.
Whoa. Everyone's gonna stop. You got the first man. Oh, God.
Kennedy's the last. Kennedy's the last.
Can't you forget this problem?
Last night.
At the very bottom, you have an equation. This is again talking about the relationship. So remember how we said that the difference between relations and functions? What was the difference? Anybody remember? You're close. Flip it. You got it, Dustin. Other way. All functions are relations. Right. So what makes a relation a function? Maya. A one-to-one connection. So that mapping diagram that had two arrows to one wouldn't be a function because it had 2 to 1. Right. Yes. So when you're given all these questions in different formats, so you're going to be giving them in equations and words and all that fun stuff, you're going to have to be able to say if it's a relation or a function. Yeah. Sounds difficult. It's not that crazy. So it is crazy. When we have an equation like this, I just have to move things around and see what's going on. We have things called dependent variables, outputs, inputs, setting coordinates. We have all these different terms. It's important that you know them all, so let's go through them. Looking at this is an equation. The input is your domain. What's your domain? From last class? Your x values, yeah. So your input is your x values. Meaning your output is your y values, which is your range. Stop. Last time. Your independent variable. So over here, we call it your independent variable because you're choosing what's actually happening to it. Meaning that it's changing on its own, where whatever happens to this one affects this one. Does that make sense? You're inputting this x value to figure out your y value. So your x value changes on its own, so that's the data you're collecting. Your y value is like the data you're receiving out of it. So we did our toothpick question. The number of toothpicks was your input value, and the output should have been the number of triangles we made. Simple? Easy peasy? Let's take a look. So consider that equation up top. The relation described by the equation y equals 2x minus 5. Complete the first 5 rows of the following table of values. So, for each input, what's the output? Practice calculating on your own. Do all 5 on your own. I'll do the first one. If the input is negative 2, all you do, take your equation. Y equals 2x minus 5. And for each of the inputs, you just put it in. So y is equal to 2. The first input is negative 2. And then minus 5. Always put brackets on your input. This should give you y is equal to negative 4 minus 5. Y is equal to negative 9. So that would go right here, my output. Now what would my ordered pair be? If my input's negative 2, my output's negative 9, my ordered pair would be negative 2, negative 9. It's whatever your input was, and it's whatever your output was. Like that. Do the other 4 on your own. It should be quick. You should be working. Oh, do it. No, you don't. Good. I know, that's what you quickly. You're struggling. The second one sure looks like this. So your y value, your output should have been negative 7. Your ordered pair should have been negative 1, comma negative 7. Wait 30 seconds, we're almost done. We should almost be done filling in that entire chart. Thank you. For 0, what's your output? -5. Yeah, because 0 should have gone in here, which would have been 0 times 2 is 0, leaving you with just -5. Making your ordered pair what time?
0,
Perfect. Make sure you put brackets around. Make sure you use the round brackets. It does matter. For 1, what would it be? Yeah. It'd be -3 would be your output. Making your ordered pair what, Colton? Yeah. And for 2, you should have got -1. And your output should have been what, Liam? 2, -1. Any questions on how that's happening? Now, use those ordered pairs to plot on this graph. So you should have a grid. Plot out those ordered pairs. I can't do it on the board because the board is broken. I'm not sure why it's broken. But go ahead. Plot them in. So your first one, what was your first order pair again? -2, -7. So your first dot should have been right here. -2, -7. -9? Right here, on the line. What a shock. Practice plotting them. Yeah, hold on. I understand that this might be easy, but you've got to practice. Try plotting it. For C. Draw a line through the dots that you put on. And you should see that it's the line that's right on there. Ready? Okay. You can then use that line in that graph to figure out what your output would be when your input is 6. Just go to 6 and follow it up. And what do we hit? It's kind of like 6 and a little bit. Right? That graph. We'll call it 6. So when you put an input of 6, you get an output of 6. Lost? 7? Perfect. So that's showing you 2 things. That your graphs aren't ever going to be perfect. So these aren't, when you're doing your graphs, it's going to be an estimation because our lines are never going to be perfectly straight, right? Our dots are never going to be perfectly on the intersection. So it's important that you can verify your stuff, which is this question right here. So plug in 6 into the equation. What's your output? Actually, 7. So if it hits 7 right on, that's perfect. This graph that is drawn on the board, it's kind of halfway in between. And you should be able to use these graphs to figure out things. So if you're like, well, what would happen if I did this? What would happen if I scored 5 goals? What are the odds that I win? And maybe the Y value gives you your percentage of winning. No. That's what it would be pretty cool if I could predict on something. I'd probably not be a teacher if I didn't care. Oh, I mean, if you could predict the future.
It's kind of like Back to the Future when they have like this the book that tells you what will happen in school.
How many of you guys have seen Back to the Future?
I've seen it over 30 times.
Yeah.
You know the thing that says like all the scores?
Yeah. Yeah, that's what I want.
Yeah. You'd win them all somewhere.
Yeah, I mean for sure. In a second, Tina's got a question.
It's my question. Back to the future. Did you ever think the space got
Yeah.
And they already have a hover bike and they're in the process of making a hoverboard.
That's awesome.
That's so cool. Okay. Anyways,
I don't know, it's probably like 30 mils.
just wait for the last part of this. Okay, guys. So, take a look at the last question. Jared, stay seated, bud. Complete the following statement. The relation that we've just built is called a blank. Because the graph in the relation is a straight line. Linear? Yeah, it's a linear relation. It's also a function. So it is a linear relationship because it's in a line. But it's also a function because of what? Because of why, Gabby? Just say it. Just say it. Doesn't want it. Keith, why is it a function? No. Why is it a function? Someone tell me.
If I tell you, can I go to the wall?
Yeah. No, hold up. Wait, pressure's on. Johnny, why is it a function? You better get some Depends, buddy. You're not going to that anytime soon.
Because it feels like it.
Why is it a function? No. Has nothing to do with its mom and dad, Josh. Dawson, why is it a function? Dawson S. The struggle's real.
Isn't it because every
Liam just saved all of you guys. Listen.
Thank you.
Liam, why is it a function?
Because for every x, there's only one y.
Yeah, because for every x, there's only one y. Yeah, I heard it over here one time. That side of the room was lost.
I totally said it.